Today's topic is called completing the square. Today we're going to focus on quadratic equations that have a value of a equal to 1. Today's April 27th, and this is the note packet that you'll need for today's lesson. Before we start the completing the square process, I just want you to recall that a rational number could take many forms. It could be a positive number, a negative number, a fraction, a repeating decimal, or a terminating decimal. The factoring methods that we have used so far only work if the roots or the solutions are rational, so they'll take one of these forms. However, it is possible to factor using another method. So the method today is called completing the square, and this method allows us to find our solutions or our roots to the quadratic equation when they are irrational. So we might see a square root radical show up. The strategy we use, completing the square, forces the quadratic equation you're given to be a perfect square trinomial. The format that looks like is here in pink. I have an a squared and a b squared at the beginning and end of my quadratic equation. Because there's a middle linear term, that tells me that my factors are identical. So instead of writing both factors, we write one factor and then we use the square. So perfect square trinomials, if we look at a couple, remember I would write this factor twice and distribute. I can see the results. I have a square in the front and a square in the back. When I look at x plus 2, square in the front, square in the back. Even if the factor is negative, I'll still have a perfect square in the front and the back. My middle term will be negative in this case. Perfect square in the front and the back. We can continue this process, but we should always notice that we have perfect squares in the front position and in the last position if we're creating a perfect square trinomial. The term in the middle, though, will change depending on the sign in each factor. We're going to go through the process with an example. It may seem a little bit slow at first, but you'll get the hang of it, and then you'll be able to go through them much quicker. So the first step is to take the equation that you were presented with and put that equation in standard form. Remember today, we only can get this process to work if the value of a, which is in front of x squared, is equal to 1. We also sometimes need to move our terms left and right. Whichever way you move them, make sure to keep your x squared positive. So this example is already in standard form. Now we're going to do a little separating. We're going to keep the quadratic term and the linear term on one side. I usually leave them on the left. And the constant of negative 80 is going to move to the other side. When we move that constant, the sign changes. We're going to force a perfect square trinomial to occur on the left-hand side. So in step 3, we need to make a little bit of room so that we can add someone to the left, but we also need to add a value to the right to keep our equation in balance. In order to find that missing value, what we want to do is, at this point, we're going to make space for a new term on the left and a term on the right. We're going to look at our linear term, which is 2x, and it is positive. We're going to take half of that coefficient, so half of that is 1. We'll square it, so what you're seeing here is half of 2 squared. And then we're going to add that value once it's squared, which is 1, to both sides. The value here that you see pointing in yellow to the 1 squared, I usually write this for the first day of problem solving so that you can get the hang of it. But once you have a good idea of how to handle it, you do not have to write this step. This is just a visual for you to know how to fill in your blanks. Now, the perfect square trinomial that you created on the left-hand side, we want to factor that and show what the two identical factors are. So I'm going to list the factors, squared, and I did simplify from the last slide the constants of 80 plus 1. The final steps are to take the square root of each side and then solve and obtain our roots. When you square root, remember there's both a positive factor and a negative factor that need consideration. When I square root the left, the squaring and the square rooting are inverse functions and they cancel each other out, leaving me with x plus 1. The square root of 81 could be both positive or negative 9, and I do need to keep the plus and minus sign there. Now, to get x by itself, we need to subtract 1 from both sides, and that will put it over on the right. And at this stage, we're going to separate. We should have two roots. So in my first solution, I have x equals, I'm going to use the positive value of 9, and now I'm going to subtract 1 to get a root at 8. When I solve it the second time, I will use the negative 9 minus 1, and I'll get a root at negative 10. So the solution set to this quadratic equation is 8 and negative 10. Okay, let's look at example 1. In this first example, we want to put it in standard form, but I'm also keeping in mind that on the left, I want the quadratic and linear term, and on the right, I want the constant. So instead of moving all the terms, I'm just going to add 16x. So now the linear and the quadratic are on one side and the constant is on the other. Now I'm going to make space to force the trinomial to be perfect. So I made room for a buddy on the left and the right. The rule says take half of positive 16, which is 8, and square it. So I'm going to fill in the blank with 64 on each side. We're going to factor the left side. My two identical factors are x plus 8 and x plus 8. And when I combine the constants, I'll get 25. We're going to square root each side. On the left, I'll have just x plus 8. But on the right, make sure you note we have both a positive and a negative 5. And at this point, we'll subtract 8 from both sides. And now that x is all alone, we're going to separate it into two factors. The first time we'll use the positive value of 5 minus 8. We have a root at negative 3. And we'll use the negative value of 5 minus 8 to get a root at negative 13. And I'll list my solution set. In example number 2, even though it's not technically in standard form, the terms on the left and the term on the right are exactly the way I want them. So now I'm just going to make space to complete the square. My linear term is negative 18. We have to consider that when we take half of it. Half of that is negative 9, and we'll square it. We're going to fill both sides in with positive 81. This sign is very important. When I factor the left side to get my identical factors, they are both x minus 9. So this is where the sign is really going to play a significant role, because if the sign is wrong here, following through the process, the sign will be wrong all the way to the end. My constants add up to 25. We're going to square root both sides. We'll have x minus 9 equals both positive and negative 5. And to get x alone, we'll add 9 to both sides. And again, this is where I separated into two roots. So the first root, we'll use the positive value of 5 plus 9 for 14. The second root, we'll use the negative value of 5 plus 9, and we have a root at 4. So my solution sets are 4 and 14. In example number 3, we have quite a few terms present. I'm looking at the 5x squared and the 4x squared. You want to decide which movement will keep x squared positive. So I'm going to subtract 4x squared to get positive 1x squared, and I'm also going to subtract 5x and put it with 21x. So We did put it in standard form. I moved both of my terms from the right to the left. Now what I'm going to do is I'm going to send the positive 60 back to the right-hand side. It will change to a negative 60. And when I do that, I'm making room for my perfect square. So half of positive 16 is 8. And we'll square it. So we're filling in the blanks with 64. My two identical factors on the left are both x plus 8. And the right side simplifies to 4. We'll square root both sides. Remember, I have both a positive and a negative 2. And we'll subtract 8 from both sides. And now it's time to separate. So in my first root, it's positive 2 minus 8. And in my second root, it's negative 2 minus 8, giving me two solutions at negative 6 and negative 10. In example 4, again, we have terms on both sides. We want to move in the direction that will keep my x squared term positive. So I'm going to add 9x squared to both sides. I'm also going to add 10x to both sides, and I'm going to leave negative 19 on the right-hand side. Or I'm not. I'm going to move it also to put it in standard form. I'm going to move it back and leave space to complete the square. My linear term is negative 20. Half of negative 20 is negative 10. When I square it, I'll fill in the blank with 100 on both sides. My two identical factors on the left are x minus 10, and my constants combine to form 81. We'll square root. And again, we want to get x alone. I'm going to add 10 to both sides. And we'll separate it into two solutions. So in my first solution, I'm using the positive value of 9 and adding 10. And in the second solution, I'm using the value of negative 9 plus 10. So my solutions are at 19 and 1. All of these examples today have given you positive or negative numbers. Your homework will be the same. But we are going to look at one more example. If you'll flip to the back and find example 9. When you have a decimal answer, you're giving me an approximation, but it makes sense in the context of these problems because we don't know how to factor them otherwise. So in example 9, this is the quadratic equation we're provided with. We want to subtract 6x so that it is on the same side as the other terms. And now I'm going to add 141 so that it's separated from my quadratic and linear term. I'm going to make space to complete the square. Half of negative 6 is negative 3. And when I square that, I'm going to fill in the blanks with 9. So far, the process is identical. On the left, my two identical factors are x minus 3. My constant is 150. This is the first time that we haven't seen a perfect square, but that's all right. We're going to move forward. We're going to square root both sides. On the left, we'll have x minus 3. On the right, we're going to leave this as positive and negative square root of 150. We can simplify this square root radical, and we'll get into that in our next lesson. But for now, I'm going to get x alone and add 3 to both sides. Now this one's a little bit different. We're going to use the positive value of the square root of 150 and add 10. Because 150 is not a perfect square, you can go ahead and type it into the calculator and add 10. Make sure you use the arrows to get out from underneath that square root radical. So I have a root at a little bit bigger than 22. My negative value of square root of 150 plus 10 gives me a value at negative 2.24745. When I write the solution set, I am going to round them off to the nearest hundredths. They would be specific and tell you how to round them. So there's my roots. They are exact locations, but I had to approximate where they were because my answers are in decimal form. This will be homework number 105. It says completing the square rational roots in your packet. If you have any questions going through the lesson or the homework, please feel free to send me an email or a text, and I'm happy to help you. Otherwise, have a great day.